Hello, everybody. I wanted to give you guys an update on the weather and then try to tie this into what we've been learning this week and in the previous weeks concerning dew point, relative humidity, low pressure, high pressure, as well as we've started to introduce troughs and ridges in the upper atmosphere. What I am showing here on the screen right now is a forecast using the NAM model, the NAM, North American model. This is a website called twisterdata.com. It's a free website that I use in forecasting because it produces some nice graphical model output. In any case, this is 12Z on Friday, so this is Friday morning for the continental United States anyway. And this is surface pressure with wind barbs, and then colors are wind speed. The brighter the colors, the more higher the wind speeds are. What I want to highlight here are a couple of features. First of all, over the south central United States, the winds are moving from west to east. So the wind barbs here are pointing towards the west. That means they're coming from the west, going towards the east. And then as you follow around the contours here, you can see that there's kind of this clockwise flow to it. This is high pressure, and you can tell that by actually looking at the numbers on the contours themselves. That's a 1024 millibar high pressure system. If you look off the coast here, there's actually 1008 millibar. That's much lower pressure. 1008 millibar low pressure system that's been moving up the coast. It actually brought us quite a bit of rain here in Maryland today. Very unsettled, very cloudy. It was actually very cool, only in the 50s today here in Maryland. So on the backside of that, northerly winds, a little bit cooler. If we go back towards the western United States, here's a 1016. So this is lower pressure than this 1024 that I first talked about. So there's lower pressure over the mountain states, and then there's high pressure right now in the Midwest and the South. I want to show you, I'm going to change this over to dew point. Okay, what is going to be shown here is a map of surface dew point contoured by color. The brighter the color, the higher the dew point is, the more water vapor is in the air. So in the deep south and over the Gulf of Mexico, there are these bright colors. These are dew points in the 60s and 70s. These blue and greens are dew points below 50 degrees, so pretty dry air. And this white area up here is dew points below 30, so very dry air. The high pressure system, pay attention to what happens. So this is, first of all, we're starting Friday morning. I'm going to jump ahead 24 hours here. So this is now Saturday morning. Notice what direction the winds are coming from here. They're from the south. Again, this is dew point. They're coming from the south. And look what happens here as I go forward in time some more. So Saturday morning, now I'm going to jump ahead to Sunday morning. Look at how much farther north those dew points have gone. So we have this orange color, this about 60-degree dew points all the way up into southern Minnesota now. These southerly winds have taken air all the way from the Gulf of Mexico and have transported it all the way into South Dakota and southern Minnesota, all because the high pressure is funneling air towards the north, as well as the lower pressure over the mountains is funneling air up from the south towards the north. Remember, east of low pressure systems, we have southerly winds, and that transports that warm, moist air towards the north. So over those 3 days, our dew points have jumped by about 20 degrees. Now, I want to jump to the upper atmosphere for a second. Why is there low pressure over the mountain states that is causing this southerly flow? We've just started to talk about this. I'm going to use 500 millibars here, so about midway through the troposphere. What we're going to find is a trough. And here's this big U shape. This is a trough of low pressure in the upper atmosphere that is driving the low pressure at the surface over the mountain states. And that's what's causing that moisture from the Gulf of Mexico to funnel northward towards southern Minnesota. So they're all connected. This low pressure in the upper atmosphere is forcing the lower pressure in the at the surface, which is then causing all of that warm, moist air to be transported northward. Since we've been talking about dew point and relative humidity, let's switch back to surface dew point. And this is the morning time on Sunday. And notice again where the orange is. This is area I would say is suitable for either thunderstorm or rain development because there's plenty of moisture there, and there's a low pressure system coming in as well. But if we just look at moisture, this orange area again, and anything brighter than that is area I would expect rainfall is potentially possible. Let's take a look at what relative humidity looks like, and I need to scroll down here. All right, so surface relative humidity, we're going to look for really dark greens. Anywhere that's really dark green is going to be 100% or near 100% relative humidity. Let's take a look at this map. As it comes up, you'll notice the area is suddenly much, much bigger. It is Sunday morning, so the lowest temperature that we see across the country or anywhere in the world is always going to be at the early morning hours. So now we see 100% relative humidity, or very near 100% relative humidity, even in the desert mountain areas. That's just because the temperature is pretty close to the dew point. It hasn't told us anything about the actual moisture content of the air, which in Nevada, and I think Lonnie could probably, I'm sorry if I pronounced your name wrong, I'm pretty sure Lonnie could tell us that it's probably pretty dry there. And if we switch back to surface dew point and look at Nevada, the dew points aren't even to 50. So there's these greens. There's a little patch of yellow maybe by Las Vegas or so, but most of these are in the 40s. And you see the stark difference between dew point and relative humidity there. As a forecaster, I want to look for this orange area. I'm not going to pay attention to those dark greens from the relative humidity map. But if I'm a local forecaster and I'm curious about whether there's going to be fog or dew on the ground, then I'll pay attention to the relative humidity to know whether or not I'm going to reach saturation that morning. So different aspects are per your consideration to look at. Is dew point going to be more important to you? For me, dew point is more important because I'm curious about where the air is going to be really sticky feeling and have potential for rain. If you're concerned about dew or fog, relative humidity is probably more concerning for you. So let's see if I'm right. Is this area that has a lot of moisture in it in the low levels going to be conducive for rain? Let's see what the model is saying. So over the past 12 hours, this is a forecast model output over the past 12 hours, a wide area here has now seen precipitation fall. And a lot of these little clusters here are probably indicative of some storms, possibly severe storms. But you can see the interconnection there, that low pressure is forcing moisture return or moisture northward from the Gulf of Mexico, which is then causing storms and rainfall to occur across a very wide portion of the country. So that's just a quick look at your weather. This plume of very warm and very moist air is actually going to overtake the entire eastern United States. And I am potentially I have to see how everything plays out, but I am potentially issuing a code orange air quality forecast for Maryland on maybe even as early as Monday, but possibly Tuesday. So we'll have to see how cloud cover and rainfall work out. But so just a little a preview there of what's coming down the pipeline. If you have any questions, just let me know.